Hello everyone, here is the video for the answers for the worksheet that was posted. Let's get started. So number 1, true or false, the probability of success P can change in repeated trials of a binomial distribution. The answer is false. Probability cannot change during the binomial distribution. Problem 2, how many ways can 3 men be chosen out of 5? So if you have a calculator, there's a probability function. There's a probability tab most of the time, and normally there's a function that will say like NC of X, or in some calculators, NC of R. Similar, they calculate the same thing. You just don't want to use like an NP of R or X, because this is for permutations, not combinations. So you don't want to use the P function on that. You just want to use your C1. When you set this up, you can either put in 5C3 and then it will pop out answer 10, or you can do it the long way, which will be 5 factorial over 3 factorial times 5 minus 3 factorial. When you do this, your 5 and 3 are going to cancel out, and you're going to get 5 times 4 up top, which is 20. And at the bottom, you're going to get your 2 factorial based off this, which is just 2. 20 divided by 2 is 10. There's your answer. Same thing for number 3. You can either put in your calculator 6, choose 3, and that'll give you answer of 20, or longhand 6 factorial over 3 factorial times 6 minus 3 factorial. I think 6 and 3 are going to cancel out here as far as that, so you're going to be left with 6 times 5 times 4 up top, divided by 3 factorial, which, if you work this out, it's 120 divided by 6, which equals 20. Get the same answer either way. I don't like how thick that pen is. I'm going to change that a little bit. There we go. Alright, so moving on. So researchers are concerned about the relationship between binge drinking and membership in a Greek life organization on a college campus. Suppose the prevalence of the binge drinking among Greek-like members is estimated to be 34%, so this is going to be our probability. The research group samples 10 students from Greek-like organizations, so this is our N. So our P equals 0.34, and N equals 10. So what is the expected number of respondents in the sample? That will be binge drinkers. Expected number, another way to say average. So all we're going to do here is take 10 times 0.34, right? Because N times P is going to give you your average of mu. So 10 times 0.34 equals 3.4, or you can round up because we can't have a fraction of a person, so we can always round up to the nearest whole person. Here, 4. What is the cumulative probability of finding binge drinkers in the sample? So we want to find the cumulative probability of finding 4 binge drinkers. So our formula we're going to use is your NC of X times P of X times Q of N minus X. And we're going to use X equal 4. So if we have 10 people, we have 10 C of 4, right? X equals 4 here. Our probability is the same, so 0.34 to the X power, which is 4. And Q, which is 1 minus P, so in this scenario it would be 0.66. 1 minus 0.34 is 0.66. To the N minus 6, so 10 minus 4, the 6th power. And when you calculate all this out, I'll actually do this one on my calculator. So 10 math probability function, choose 4, you get 210, 0.34 to the 4th power, 0.0133, and 0.66 to the 6th, 0.08265. When you multiply all this out, equals 0.23084. So I know some of you are thinking, you're like, well, that's the probability of 4. And you're right, that's just the probability of 4. We wanted cumulative probability. So when you find the probability of 4, that is just defining actually 4. To find the cumulative probability, we have to take their probability of PR of x equals 0, and the probability of x equaling 1, 2, 3, 4, and add them all up, which is what I had on the answer sheet. So you already did the probability of, or no, on this one you didn't do it. I did it on my side. But this is the probability of 4, which we got, which would be 0.231952. Probability of 0, so we can work that one out too real quick, because 0 is normally a really easy one. So NC of x of 0 is always going to be 1, which if you did that would be 10, choose 0, would be 1.34 to the 0 power, always going to be 1. So really this one's always going to be 0.66 to the 10th power, which is 0.01568, which is the probability of 0. When you replace x in your calculations and add them all up, 0.0807 for 1, 0.18729, and 0.25729 for 3. When you add them all up, you're going to get a cumulative probability of 0.773. You're just replacing x in the equation with 0, 1, 2, 3, 4, adding all up to find the total cumulative probability. Part 5. Researchers are concerned about binge drinking habits of young women enrolled at their university that are members of a sorority. Suppose the prevalence of binge drinking among sorority members is 0.26. Research team samples a group of 6 sorority members. What is the expected number of sororities that were reported drinking? So expected number, once again, is just going to be your n times p, which equals your mu, which is your average, so 0.26 times 6 equals 1.56, or approximately 2 people. Next part. What is the probability? Probability between 2 and 3 respondents reporting the behavior. So this one, we have to find the probability of x equaling 2 and the probability of x equaling 3. We're going to take our, in the book they have it, this would be like your b and your a, and you take your b minus a to find the probability in between. But we have to find the probability of 2 and 3. So when you find that probability, you can go 6, choose 2 times 0.26 squared times 0.74 to the 4th, which is going to give you 15 times 0.0676 times 0.29986. That equals 0.30405. The other way you can do for probability of x equaling 3, 6, choose 3 times 0.26 to the 3rd times 0.74 to the 3rd, 20 times 0.017576 times 0.405224. Multiply all that out, you get 0.14244. Your b minus a, so 0.3040, 0.30405 minus 0.14244. You get an answer. Oh, I gave you the answer up here because I'm looking at the wrong spot. You're going to get an answer. Oh no, that actually is right. Your answer is 0.16162. This is correct. I'll probably delete the whole thing. Yeah. When you multiply that out, you get 0.14244. Sorry about that. And that is the probability between 2 and 3 respondents. So I'm going to do number 6 and number 7, and then I will stop the video and then post the next one going over that. So number 6, after reading the problem, we know that we have a prevalence of our cognitive impaired related disorders in children in the community at large is 7%. So that's our probability is 0.07. The researchers collect samples from 9 children and find that 3 children reported cognitive impairments. So the first part is what is the expected number of children that should report cognitive impairment related to symptoms. Once again, that's our n times p equals mu, n equaling 9 times the probability of 0.07 equals 0.63, or approximately 1, rounding up to the nearest whole child. So what is the probability associated with the findings presented in the survey? Is a probability 3. So what is it at 3? So we put in our formula. So 9 choose 3 times our probability of p, which is 0.07 to the 3rd power, times a q, which is 1 minus p, which is 0.93, and to the n minus x power, which will be 6. 9 choose 3 is 84 times 3.43 times 10 to the negative 4th times 0.64699 equals 0.0186. So that is your probability associated with finding exactly 3 in this population. The last one for this video is number 7. Find z percentiles. So the way we find z percentiles is you go to the back of the book and you find where you would find 11% in table B. The closest number, I like to do closest number without going over. Other people like to find the exact closest number, but if you either one, it will be fine on the exam because it's going to be relatively the same number. But you go to the back of the book and you find the closest number without going over to 11%, and you find that's negative 1.23. So once again, if you have your book in front of you, if you go to the table B, if you look in there and you try to find 11%, there is no exactly 11%, but you'll see 10.93 and 11, or 10.93 and 11.12 or 11.2% or 10.93%. So the 11% is truly in between those numbers. We don't know the exact number, so what I like to do is just do the closest without going over, which would be 1.23. So you'd see that the z-score associated with that is negative 1.23. For the rest of these, you do the same thing. You find 22%, the closest number without going over, and you'll see it's a negative 0.78. For z percentile of 0.46, 0.11, 0.75 is 0.67, and for your z of 95, it'll be 1.64. Okay, those are pretty easy to find. In the back, just find the number associated and then find a z-score that corresponds to that percentile. I will get the next video up, and or I'll see you in the next video.